Hi children, in this class we are going to discuss about derived logic gates. So in that last class we discussed what is fundamental logic gates and which are the gates, which are the operators, like that we saw. Now we are going to see derived logic gates, that is NOR gate, bubbled AND gate. It is one of the variety. NAND and then bubbled OR gate, XOR gate, XNOR gate. And one more is theorems of Boolean algebra. So these are the topics we are going to discuss in this class. So first we will see the NOR gate. NOR gate is the opposite for OR gate. Opposite for OR gate. So we already know the output for OR gate, that is 0, 1, 1, 1. Now how it will work is, in this NOR gate, if all the inputs are false, then the result becomes true. If any one input or all the input is true, the result becomes false. This is the concept. Now we will see, this is the logic circuit. See, in that last class we discussed logic symbol, we know. Here we are going to see logic circuit, that is using the 2-3 gates, 2-3 logic symbols. If you combine, that is called as logic circuit. See here, A, B, they joined using the OR gate, A or B, and then you will get one answer, that is the OR gate output should be used with the NOT gate, because NOR is a combination of OR and NOT gate. So first we want to find out the answer for OR gate. That answer should be used with the NOT gate, that is they gave here. So first gate is OR gate, or logic symbol. We got one output. That output they gave input for the NOT gate. So after that you will get the answer as C equal to A plus B the whole dash. This is the output for NOR gate. See, this is the logic symbol. A, B with OR symbol, they include one bubble, that is called as NOR gate logic symbol. So this is logic circuit and this one is logic symbol. And the output, how we are going to write is, see, C equal to A plus B the whole dash, that is C equal to NOT of A plus B, NOT of A or B, or we can tell A plus B complement. See here the examples. C equal to 0 plus 0 the whole complement. So 0 plus 0 the whole complement, we will get the answer as 0 complement. 0 complement is 1, that is both inputs are false. Automatically the result becomes false. So the bar, we have to take the opposite. So it becomes 1. This is called as NOR gate. And the NOR gate truth table is, see here, this is the truth table of NOR gate. A and B are considered as input, C is the output. See here, both inputs are false, the result becomes true. Here any one input or two inputs are true, the result becomes false. This is the truth table for NOR gate. Now, next we are going to see bubbled AND gate. So, what is bubbled means? For the input value, we are going to take the negative, that is complement we are going to take. So, the first one A, then use the NOT gate to get the negative, that is inverse values. So, A means the input we have to take it as a complement. So, bubbled AND gate you are going to use the input as a normal value we are going to use, but for the output if you want to take, we should use the complement values. So, A is input means we can find out the answer with A complement, and B is a input means we have to find the answer with the B complement. See, that only they gave in this logic circuit. A complement, B complement. So, that complement values you are going to take for the AND gate. So, first one A complement, B complement will becomes input for the AND gate. So, the answer becomes C equal to A complement dot B complement, and the logic symbol is like this: A bubble and then B bubble. So, that bubble will denote starting itself we want to take the negative. Then you can use the AND symbol. The output you are going to write is C equal to A complement dot B complement, and we can see the implementations of values. See here, we can implement. For example, the first truth table we just consider A is 0 and then first A 0 0 1 1. See here they gave A is 0, first second one 0 and third step 1, fourth step also 1, and the B value just to take 0 1 0 1. Here they gave 0 1 0 1. How they calculated the output is, first we want to take the complement value, that is C equal to, first A complement is 0 complement dot 0 complement. So, 0 complement becomes 1, again it becomes 1. So, 1 into, that is using the AND gate, it becomes. So, first what we are going to do is, we want to find out the complement for the A value and B value. So, in that here they find out the complement. The first one 1.1 into 1, the second one is A is 1, B is 0, third one is A is 0, B is 1, the last one is A and B both becomes 0. Now, these values you are going to use with the AND gate. So, AND gate means which value have positive numbers, that is true values, you will get the answer as 1. The remaining all will becomes 0. In that way, this truth table you got the answer as first one 1, the remaining all zeros. So, that you can write here as A plus B the whole complement is equal to A complement dot B complement. It is one of the De Morgan's theorem. So, A plus B the whole complement equal to A complement into B complement. This theorem you already studied in that 10th standard and all. So, it is easy for you. The next one is NAND gate. We already studied what is NAND operator. That is a combination of NOT and AND gate. So, I think you all clear in that. So, we will see the logic symbols here. See, this is the logic circuit. First, A and B, using AND gate you want to get output. That output you have to give input as a NOT gate, input for the NOT gate. So, you will get C equal to A dot B the whole dash. So, first AND gate output is A dot B. If you take NOT for that, that is inverse for that, you will get C equal to A dot B the whole dash. And the symbol is ABC with the bubble. And this is the output for NAND gate. C equal to A dot B the whole dash. C equal to A dot B the whole dash. In this, they explained C equal to 1 dot 1. If both inputs becomes 1, what will be the answer? 1 into 1. Use AND gate. 1 1 means answer 1. 1's complement is 0. Just see, this is the truth table. 0 0. So, 0 0 means use AND gate, you will get the answer as 0. So, 0's complement is 1. Again here also 0 1. You will get the answer as 0 because any one input only true. So, here you will get the answer as 0. 0 complement is 1. So, like that the remaining 2 also. Got it. Next one is bubbled OR gate. This is like a bubbled AND gate. You are going to take the input value as a complement value. So, starting itself we are going to use negative, that is inverse values. So, use AND gate. So, A means A complement, B means use NOT gate for B complement. So, that A complement and B complement want to combine with the OR gate, you will get the answer. So, that output will be A complement plus B complement. See here, this is the circuit. You can write C equal to A complement plus B complement. This is a logic symbol. So, first you are going to use the negative values, that is inversion. So, A inverse then B inverse, you will get the answer as a C. Here, this is the truth table for bubbled OR gate. Input and then here is the output value. So, 0 or 0. So, 0 or 0 means answer is 0. For that 0, if you take complement, you will get 1. 0, 1. So, any one input is true, the answer is true. In bubbled OR gate, so here 0, 1. So, you have to take a complement for this. So, first A complement is 1, B complement is 0. So, any one input is 0, again you will get the answer as 1. For the first step, how they got 1 is A complement is 1, again B complement is 1. So, you will get 1. This. So, second one, A complement is 1, B complement is 0. So, any 1 is 1, 1. Here also, A complement is 0, B complement is 1. So, both any one is true, so the output is true. Then last one, A complement is 0, B complement also 0. So the answer becomes 0. So like this they created the bubbled OR gate truth table. And here this is also one of the De Morgan's theorem, that is A dot B the whole complement equal to A complement plus B complement. How they gave this De Morgan's theorem is, you just take the previous class. There you will get one truth table. You just compare the truth table where you get the same answer. So it will show it is the equivalent. So for the A dot B the whole dash also you got the same answer. So we can tell it is the De Morgan's second theorem. So the next one is XOR gate. So the XOR gate means, just if you want to, if you remember that easily, we can tell that is any one input is true, then the output is 1. If both inputs, that is if you have 2-3 inputs are there, if any one input is true, only for that you will get the answer as true. Otherwise it is false. That is, if we have 2 false, all inputs are false, or all the inputs are true, for both time you will get the answer as false. If any one input is true, then you will get the answer as true. This is the short explanation for this XOR gate. That is, any one input is true, the result is true. Any two or all the inputs is true, or all inputs are false. Both time you will get the answer as false. And this is the logic circuit, because here we are going to use both, that is normal ordinary variables as well as inverse of that variable. That is, A is also going to use, and A complement is also going to use. Here 2 variables are there, so we have 2 variables, 2 complement variables. A complement, B complement is there. So the circuit, first how they designed is, A they took complement value, so it got A complement, and B they took complement, B complement they got it. So what they did here in this circuit is, first they took A complement value, A complement, and here from B value they took the positive, that is B before complement. So A complement B, they joined using the AND gate. So they got A complement dot B. The next step is, they took A value without complement. So A value, after that B complement value. So the next, here they joined using the AND gate. So you got A dot B, A dot B complement. So these 2 circuits they added using the OR gate. So the answer becomes, see here, A complement dot B, OR gate symbol plus, next A dot B complement. So this is the output, and they used the, and this is the truth table for XOR gate. See here both inputs A and B is 0, the result you got it as 0. A input is 0, B input 1, the result is 1. A input 1, B input 0, the result is 1. Both input A and B also true, but we got the answer as false, 0. And this is the truth table. And we can write the logic operator is encircled plus, that is a plus within circle is called as encircled plus, and this is the logic symbol for XOR gate. The next one is XNOR gate. So this XNOR gate is, in this XNOR gate, if the symbol is if all the inputs are true or all inputs are false, you will get the answer as 1. Just it is opposite for the XOR gate. That is, XOR means exclusive OR. XNOR means exclusive NOR. Okay, so XNOR gate is opposite for XOR gate. Okay, how we got answer for the XOR? Just opposite. So here, this is the logic circuit for XNOR gate. That is, here they used XOR gate because I told XNOR is the opposite for XOR. So we can use XOR gate here. A encircled B. Okay, then using the NOT symbol, we got A encircled B complement. Okay, so see, this is the expansion for that. C equal to A encircled plus B, the whole complement. So A encircled plus B means what? A complement dot B plus A plus B complement. Okay, so that you can write it as AB plus A complement B complement. Using the De Morgan's theorem, we did like that. And this is the output for X and write it as C A encircled dot B dot. So that is what De Morgan's theorem. Just to go through these theorems also, and that theorem they derived. These theorems can derive only with the 0 letter. Once using 0 and 1, we can derive these theorems. And in the next table, they describe all the logical gates. Which are the logical gates they gave in your textbook? They gave logic gates, symbols as well as truth tables. So these tables, it's easy their